I would now like to introduce Bob Langer. Bob is the Institute professor, and he's been a board member of the McGovern Institute from the very beginning. He has been a source of wisdom and encouragement all these years. I always look forward to when Bob Langer joins our board meeting, and he's going to give us the keynote lecture today on it's some sort of journey.
The slides up. Thank you. Well, thank you very much. Is it sound working? Thank you very much. You got to hear some outstanding music before, and that may not exactly fit in with neuroscience, but it was terrific. Now you're going to hear something from an engineer, and who knows. Phil said maybe he doesn't know neuroscience. Well, believe me, I know it a lot less. But I'm honored really to have been a part of the board for many years, and since the beginning, and so I thought I'd tell you a little bit about my own journey at MIT, which is different, but Bob mentioned to me about the possibility of talking about how research can lead to collaboration on the one hand, but also how research can lead to things that maybe can affect people around the world. And so I'll try to do that as well. But before I do, I thought I would say a few words about some people. I must have been about 1980. I was consulting for a company in California, in Palo Alto. And they said, Bob, there's this dinner speaker that we all want to take you to and listen to. And he actually makes these computer magazines. And that was Pat McGovern. And I remember, he had been talking about, it was really amazing how incredibly successful he was and the enormous influence that he had. So that was the first time I'd heard that. And, of course, as I followed his remarkable career, and actually Laurie's remarkable career over the years, it was, just a pleasure to watch that. And really what they did for MIT, and actually what they did for neuroscience, the gift that they gave, it was really transformational. And it really, I think, forever changed MIT's position and actually the kind of science that could be done here, and really changed the world in terms of neuroscience. It's just been remarkable to see what's happened since the McGovern Institute was founded. And you'll hear that more and more this afternoon. And really between, and of course, both of them were on the board, and Laurie still has, it's amazing, I love being on the board to listen to her comments. I mean, she certainly is not going to be shy about giving opinions, and really it's made a giant difference. I also actually have this picture, and you just heard from Phil, but just as again, an outsider, as I've been at MIT myself now as a graduate student and a professor for actually the last, it's hard for me to believe, 55 years. I can think of no individual that has really made MIT great more than Phil. I mean, he, as both a leader, biology department of the Cancer Institute, then of the McGovern Institute, and really just the incredible advice he's given to everybody at MIT and the vision he's had. It's been absolutely remarkable. And that's separate from the fact that he's an unbelievable scientist and has changed the world that way too. And an incredibly nice guy. So he really got this all started, and and then actually I think it was 2004 maybe, but we were doing the search, and we were so fortunate to get Bob as the head, and he has just done an amazing job. I mean, to watch the growth of what has happened at the McGovern Institute, and to see all the tremendous young people and what's been going on, it's absolutely remarkable. So it's really been a privilege to be a spectator on the board. So with that said, I thought I would tell you a little bit, and like I say, it's very different. It's just my personal journey for entertainment, I guess. That that I thought I'd go over, and how I got into this. So I got my degree in chemical engineering in 1974, and when I did, pretty much all my colleagues in chemical engineering, graduate students, went to work for oil companies. There was a gas shortage then, and if you actually lived in Boston, you had to wait in line for 2 hours at a gas station to get your tank filled. The consequence of that, though, is that if you were a chemical engineer, you got a lot of job offers. And so that's what all my friends did. I thought that's what I'd do too. So I applied to oil companies. I actually got 20 job offers, 4 from Exxon alone. And I wasn't very good, but I just, they'd hire anybody. So, especially if they were from MIT. But one of those interviews really made quite an impression on me. They had some MIT graduates from 1966 in Exxon in Baton Rouge, Louisiana. And they told me, gee, if I could just increase the yield of this one petrochemical by some very tiny percentage, they said it'd be fantastic. It'd be worth billions of dollars. And I remember flying back to Boston that night thinking to myself, I really didn't want to do that. and in fact, of all those jobs, so I didn't do that. And so I started to think what I did want to do. And when I was a graduate student, I was supposed to be doing my PhD thesis. I got very involved in starting an alternative high school in Cambridge for working class students. And I got very involved in creating new chemistry curriculum. And one day I saw an ad at City College of New York to be an assistant professor to do just that. So I wrote them a letter applying for a job, but they didn't write me back. But I liked that idea, so I found all the ads I could to do something like that. I found about 40. I wrote to all these places, and I don't think any of them wrote me back. So that wasn't going so well, so I started to think, what other way could I use my chemical engineering background to help people? And I thought about medicine. So I wrote to a lot of hospitals and medical schools. None of them wrote me back either. But then one day I was walking into the lab where I was, and one of the older scientists said to me, he said, Bob, he said, there's a surgeon in Boston named Judah Folkman. And he said, sometimes he hires unusual people. He thought very highly of Dr. Folkman, but I don't know exactly what he thought about me. But anyway, I wrote to Dr. Folkman, and Dr. Folkman had this idea that if you could stop blood vessels, that might be a whole new way to think about treating cancer. And he also thought that there was a chemical he called TAF, tumor angiogenesis factor, that caused these vessels to grow. Now, it turns out that people were incredibly skeptical of this theory. I didn't know any biology. I still don't know very much, but I thought it was great, so I went to work there. It was by far the lowest paying job, and I was the only engineer in Children's Hospital. But I learned a tremendous amount. Anyhow, he said, Bob, what he wanted me to do was prove he was right, but in so doing, isolate the first, what we call angiogenesis inhibitor. Now, the biggest problem that we faced at that time was there was really no way to study blood vessel growth. And the reason for that is almost everywhere you'd look in any organism or person, there's always background blood vessels. So that's not so easy. So we had to invent an approach. And what we did, there's a certain places like the chick choriolentoic membrane or a cornea that doesn't have blood vessels. So our idea was maybe we could put certain tumors in them, which would cause blood vessels to grow. And then maybe we'd have a tiny delivery system, like a microparticle or nanoparticle, that could deliver the molecules we wanted to deliver. And the molecules we wanted to deliver were pretty big molecules. So at that time, 1974, there was almost no work going on in advanced drug delivery systems. In fact, there was only one company in the world then that was working on them. It was a company called Alza out in California, actually in Palo Alto. And Dr. Folkman was on their advisory board, and they had actually Nobel Prize winners in chemistry on their advisory board, and he asked them, could they help us? But what they all said was no. They said, by the way, that company would later make transdermal delivery systems, but all for small molecules. But they all said to him that you really aren't going to be able to do it because they can't get through solid materials any more than like we could walk through a wall. So on the other hand, if we were going to solve the blood vessel problem, we had to solve this problem. So I actually spent 2 years working on this, experimenting with different materials, different techniques. I actually found over 200 different ways to get this to not work. But eventually, we made these little tiny particles. You see a picture of one and one cut in half. And we published in the British journal Nature that you could use this to release molecules of any size. It's also the first time that nucleic acids, which DNA and RNA are, were delivered from the tiny particles. So I want to go back, though, to about 3 months before this paper came out. I got asked to give a talk at a major scientific meeting. I was 27 years old then. It was 1976. And so I practiced this talk for weeks into a tape recorder. And finally the day came, and I got up and I gave the talk. And I was by far the youngest person there. There were a lot of very well-known scientists there. And I thought at the end of the talk, I didn't do too badly. I didn't forget too much what I was going to say, or I didn't stammer too much. So I thought when I was done, all these older scientists, being nice people, would want to encourage me, this young guy. But when I got done, I stepped off the podium, and a whole bunch of them came up to me, and they said, "We don't believe anything you just said." And they said the molecules were too big, and the solvents we were using, methylene chloride and ethanol, they destroy whatever we put in. And actually, things went downhill for me there. My first 9 grants to the NIH and other places got rejected. Largely, I still remember one of the ones, because it was a cancer grant. They said, well, Dr. Langer is an engineer. He knows nothing about biology and even less about oncology. I thought mathematically that was hard to do, but nonetheless, I didn't do too well. And then, I tried to, I loved being a postdoc, but a lot of my friends gave me advice. They said, probably you shouldn't do that forever. So I applied to faculty positions, and I applied to chemical engineering departments because that's my background. But actually, no chemical engineering department in the world would offer me a job. They all said, well, you want to do this bio stuff, you should be doing energy or oil or mathematical modeling. So I didn't get any jobs there. The reason I got one finally is Nevin Scrimshaw, who was head of the nutrition department. I don't know if anybody knew Nevin, but he was what I call a benevolent dictator kind of department head. And what I mean by that is, he liked me, so he offered me a job, but he didn't ask anybody else in the department what they thought. But which would have been okay, except for one thing, which was that the year after I joined the department, he left. So a lot of the senior faculty decided to give me advice, and their advice is I should leave too. And in fact, a number of years ago, I got some award, and they asked Mike Marletta, who was one of my colleagues at the time, to say a few words, and so he later became chair at Berkeley, head of Scripps. He was a very famous scientist, but he was giving a talk about what it was like to be with me in 1979, and what he said, I'll just read it. He said, this is a direct quote. They even published it. It said, one evening I went to a faculty dinner at a Chinese restaurant with myself and MIT professors. He said, a senior scientist sat quizzing us while smoking a cigar. He said, when the older scientist heard my concepts for drug delivery, he blew a cloud of smoke in my face and said, you better start looking for another job. So I had a pretty inauspicious beginning, but I had wonderful students here, and I kept trying. And we did actually, with that was the assay that I mentioned, and I'm just trying to see if I have to apologize for this next picture, but there's no other way to show blood vessels, so I'll show it quickly. But we did actually use this assay, and we did actually publish in the journal Science that inhibitors did exist, and I'll show it very quickly, but what you'll see is on the left, that's what you normally get. On the right, and we did that over 2,000 tests. We had lots of controls because most of the molecules we tested didn't work. But when you do put an inhibitor in, we repeated this 21 times, notice how the vessels are lower and they're sparser. And so basically, I just want to turn that off for a second. So that actually showed for the first time that blood vessels inhibitors did exist, but it would also provide assays that people could then use and continue to use to this day to find out if they have inhibitors or not. And so what would happen, medicine doesn't happen quickly, the translational part. So we published that in 1976. It took another 28 years and really terrific work out of Genentech and other places before the first blood vessel inhibitor would get approved. But starting in 2004, so that was actually the year Bob would come, something remarkable would happen, and I will just show you that. And what you see is Avastin gets approved. Actually, that's Genentech's drug, which is probably the number 2 or 3 best-selling biotech drug in history. But you see they keep going, even to last year, and they'll keep going. Nature, the journal, estimates that 500 million people will use these. And they're not only the treatments for almost many kinds of cancer, they're really the only treatments for diseases of blindness in the back of the eye, like macular degeneration or diabetic retinopathy. Now, one other thing that I wanted to mention, which on translation, is that, Dr. Folkman and I talked about writing a patent. And so, at that time, at Children's Hospital never had a patent. And so we filed one for the first time, and 5 years in a row it got rejected. And I remember the tech transfer people coming down to see me, and they said, Bob, you're wasting so much money for the hospital, you just should quit. But I don't like to quit. And I started to think, how could we convince the patent examiner to allow this patent, legally, of course? And science really wasn't working, right? But I remembered, as I told you, when I first started doing this, everyone said it was impossible, it could never work. I wondered, maybe somebody wrote that down. So you can do something called a science citation search, meaning you could look back at your Nature paper and see who wrote about it. So now in 1982, 6 years after that came out and after all these rejections, I did that, and I found, well, I'll just show you one article. But this is from 5 of the top material scientists in the world, and they had written this 3 years earlier. I had no idea they wrote it, but I'll just read it to you. They were basically describing this field, and they said generally the agent to be released is a relatively large, small molecule. One wouldn't expect that macromolecules could be released because of their extremely small permeation rates. However, Folkman and myself have reported some surprising results that clearly demonstrate the opposite. So I really like that word, surprising. And so we showed it to the people at the hospital. They flew down to Washington to show it to the examiner. And he said, gee, he had no idea. He said, he'd tell you what, I will allow this patent. He said, if Dr. Langer can get written affidavits from each of these 5 people that they really wrote this. So it's a true story. I wrote them, and they were nice enough to write me back. They really did write it. And we got this really broad patent. And with that, finally, what happened is so I'd finally get calls from some of these giant companies, and they'd say, well, we'd like you to consult for us. And the two multi-billion-dollar companies, they licensed the patent, they gave me a grant, and they gave me a consulting fee. And I was so excited that finally something I did might make a difference in the world. But what happened was, after a year or two, they did some experiments, didn't turn out exactly the way they want, so they gave up. But then Alex Klebanoff, one of my good friends and professor at MIT at the time, said, Bob, we should start our own company. So we did that. We started a little company, and we've kept doing that. And I've gotten involved in a number of translational things, all from different things we've done at MIT. And some of them are based on those companies, some on our patents, some just on the science we've done. But the consequence of that is now drug delivery systems are used for, like this, based on what we did. They're used for all kinds of things, really for actually billions of people. In particular, more recently, one of the companies I helped start, which is based on nanotechnology drug delivery systems, is Moderna. But here's one that Phil and I were both involved in, which came from Alnylam. And yet, I hope nobody has some of these, but drug-eluting stents are widely used for treating heart disease, and many, many others here. In fact, from a neuroscience standpoint, a little bit, some of these treatments end up using for schizophrenia and actually opioid addiction. So there are many of these. And we've continued to do work on other areas as well from a basic science standpoint. And one of the other ones that we've been very involved in is creating new tissues and organs from scratch. And I put some of these on. And these could provide new tools, including even trying to create brains on a chip. But basically, these are all things that, and many of these have now become real treatments, like making new skin for burn victims. And actually, Laura Nicholson, one of my students who went to Yale, actually created a new way to make new blood vessels that's now being used for soldiers in the Ukraine and was just approved by the FDA about 2 months ago. the last thing I thought I'd try to say is the point about collaboration. I mean, all this happened because of so many great people at MIT and elsewhere. And anything that you do, which really ends up having these effects, is the work of many people. So I thought, as Bob had mentioned to me about collaboration, I just went through actually looking at the people who are on the McGovern faculty that I've actually had the pleasure of interacting with in different ways. And so actually, and when I looked at this, it's pretty much half of the people I've ended up working with in some way or another, some on paper, some on patents, some on boards, and others. And these are all just the things that have come out from them and from all of you, and really have just been absolutely remarkable. So for me, it's been an honor to work with the different people at the McGovern, to watch and be a part of the board, to see the amazing work that's been done. And I just want to thank everybody here for what they've done for the McGovern, and it's been an honor for me to present this today. Thanks so much.